Okay, so this is chapter 1, section 5, and we're continuing to talk about slope. And we're going to change the word that we're using for slope. We're going to talk about the average rate of change now. And the average rate of change is really just our change in y over the change in x. And rather than using y1 and y2 now, we're going to use f of x2 and f of x1. Because really those mean the same thing as y2 and y1. And just a couple notes before we actually move on. Parallel lines, remember, they have the same slope. Perpendicular lines, they have the opposite and the reciprocal slope. So if we have a slope of a over b, then the line perpendicular to it has a slope of negative b over a. Let's look at a couple examples here. It says, write the equation of the line in slope-intercept form that passes through 5, negative 9, and is perpendicular to this line right here. Now, it says perpendicular, so remember that whatever this slope is, we want the opposite and reciprocal slope. And we want slope-intercept form. Remember that's y equals mx plus b. So we have the point 5, negative 9. Okay, and we want to figure out, well, what is the opposite and reciprocal slope of this function here? So first of all, let's get y by itself. And subtracting x, we have 7y, and adding 12 is equal to negative x plus 12, and dividing by 7, y is equal to negative 1 over 7x plus 12 over 7. And a lot of times students will see this and kind of get nervous. This doesn't matter to us at all. All we're interested in is this slope. And we want the perpendicular slope. So the slope perpendicular to this would be positive, so opposite, and then the reciprocal, so 7. So m is equal to 7. That's what we want from this. Now, we also want to use this point here, 5, negative 9. And I'm going to start out with y minus y1 equals m times x minus x1. Remember that's point slope form. And this is my x1, this is my y1. So y minus negative 9 is equal to 7 times x minus 5. And now we just want to turn that into slope-intercept form. So distributing the 7, we're going to get 7x and negative 35. And this is a positive 9 now. And so we want to subtract 9. So we have negative 35 minus 9 is going to be negative 44. And that's our equation. That's the equation of the line that goes through this point and is perpendicular to this line. Now looking at the next example, it says find the average rate of change from x1 to x2, where f of x is equal to this function here, x1 is 3, and x2 is 6. So we want the average rate of change, so f of x2 minus f of x1 over x2 minus x1. So that's going to be 6 minus 3 on the bottom. And then we want to find f of x2. Well, plugging into our function, x2 is 6. 6 squared is 36. 2 times 6 is 12. 36 minus 12 is 24. And then x1 is 3, so 3 squared is 9, minus 2 times 3 is 6, so 9 minus 6 is 3. And now we have 21 over 3. And that's 7. So 7 is our average rate of change. Now we can also talk about the average velocity of an object, and you'll notice that this function looks very similar to this one. And that's because it's really the same thing. It's the change in one variable over the change in the other variable. So looking at this example here, we want to go ahead and find the average velocity of this object. And it says s of t equals 5t squared represents a ball rolling down a ramp. T is equal to time in seconds after the ball is let go. S of t is the feet traveled. Find the ball's average velocity, t1 seconds, t1 equals 2 seconds, and t2 equals 3 seconds. So, same thing we were just doing. t2 is 3, t1 is 2, and then s of 2 and s of 3. So plugging in 3 here, 3 squared is 9, 9 times 5 is 45, And then 2 squared is 4, times 5 is 20. So that's going to be 25 over 1, or 25 feet per second. And that's our average velocity. And that is the end of section 5.